Hi, my name's Greg Smith, aka Dr. Frankentosh, and today we have a special visitor, the Freewrite Traveler by Astrohaus. Obviously not an Apple product, normally retails for about $500, but I got mine for $100 because, well, it's got a broken keyboard. I had reviewed this product a couple of years ago on another channel, so I put that link down below. So today, let's look at fixing the Freewrite Traveler keyboard on Dr. Frankentosh. So our story starts last month when I was working on the clamshell touchpad. Originally I thought that it was a PS2 mouse emulator, and so I was going to need some sort of terminal in order to read the mouse, like it was a serial port. So I went looking for VT100s, and oh my god, they were expensive. So I found this guy who was emulating a VT100 using the VGA32 board, and that led me to the FabGL library built by Fabrizio Di Vittorio, and I thought, that's perfect. And so I got the parts, built my emulator, it worked, and then I realized I'm going to need a box to put this in. So I remembered I did this review 3 years ago and thought that would be perfect for this. And so I went looking for one on eBay, and oh my god, they were expensive. And so I thought, okay, well, maybe I can find one that's used. And I did. I found one that's used, but it was broken. It had a bad keyboard. And I thought, well, didn't I just do a keyboard repair? Yes, I did do a keyboard repair, so I should know how to fix this. Sure enough, the broken Freewrite arrived with a stuck key number 2, which we are going to fix, and that brings us to our project for today. Astrohaus is the company that makes this Freewrite Traveler. They were started in 2014. They created a Kickstarter for this thing called the Hemingwright, which was a sort of a retro steampunk distraction-free keyboard and e-ink display. With the success of that, they then renamed the device to the Freewrite, and then created this new device called the Traveler, and we'll get to that in a second. Their latest offering is a product called the Alpha, which is a slimmed-down version of the Traveler, and they just added the Clap Boss, which looks a lot like the Clapper from the late 1990s. So the project for today is to take a look at this keyboard. The number 2 key is stuck, which means it's repeating and practically nothing else can be typed. The device seems to work in every other way, so we're in good shape for repurposing this down the road, or just using it as a Freewrite Traveler, if indeed we can fix it. To take the case apart, we first have to move the little rubber footies out of the way. They're hiding the actual screws which are holding the device together, and once we get those out of the way, the rest of the unit will pry apart, and we have to be careful while prying it apart not to break the inner tabs. Once the case is separated, the keyboard lifts up to expose the circuit board and battery. Now with the PCB exposed, it's time to start removing the screws that will allow the PCB to be pulled away from the chassis. So you'll need to be careful when dealing with the display cable. It's really fragile. There's a clip for a zero insertion force socket that needs to be undone. That's really sensitive. I found it very challenging to pull it apart. But once you do, you still have to desolder the metal sheath that goes around the cable from the rest of the board, and I actually had to cut it a little bit to pull it away. Here you can see the spot where I carefully cut the sheath, and also you'll want to disconnect the battery to make sure that you turn the unit off and can work safely with the device. And now it's time to disconnect the hinges from the base unit and remove the display. Here you can see the completely disassembled base unit plus how it looks from the top with everything disconnected. I've already removed some of these screws, but here I'm identifying the location of the screws that hold the keyboard to the chassis, and once these are removed, then the keyboard will just drop right out. So here I've flipped the keyboard over, and I'll tilt it up to try and get it to let gravity pull the keyboard down, and then gently pull the keyboard away. And you'll notice that the ribbon cable goes through a slot in the board, and so you need to gently pull that through as well. So I think this rubber bit is glued on, which is unusual. And I'm going to try and peel it off. I'm going to stick it onto this over here to hold on to it. Okay, I'm going to cautiously and carefully apply a little bit of heat and see if that will loosen that up. But I have to be careful not to damage the membrane. So at this point, I kind of made a fateful mistake in the category of do what I say and not what I do. I wasn't careful when applying heat, and as it turned out, I really didn't need to remove this nubbin or nipple because the ultimate solution was to slide a piece of tape underneath the membrane to prevent the short. And I ended up damaging some surrounding keys. Yeah, you can see if you look at the number 3 there, I've already damaged, I've noticed that I've damaged these keys. Pulling this nipple away helped me see how this is constructed, so it was useful, but in the end, I don't think that it was a good idea. And soon, once we get past the repair, I'll go back and I'll show you how I fixed these 4 keys. I had a lot of help from the folks at Astrohaus who were really, really supportive. But once again, you need to be really careful when you use heat on a project. I really didn't think that these keys were going to be that sensitive, but if I had been thinking about it, I would have pulled these keys off as well. And of course, now in hindsight, I've learned that I really didn't even need to remove this rubber nipple. So I've got a piece of this high temperature tape and folded it to the right size and slid it in between the membrane to prevent the key from repeating as it acts as an insulator. So I reconnected the battery, the circuit board to the keyboard and to the display, applied some power, and it reboots. And so now we're waiting for the moment of truth. Did we actually get it to work? Now these stream of 2s that you see here are left over from the previous entry before we put everything back together. So I'm going to remove some of these old string of 2s and now tap some of the keys surrounding the 2. And as you can see, the 3, 4, W, Q, and 1 and 3 keys are all working, and we aren't getting the repeating 2. So we've successfully solved the immediate problem. So we're going to put this back together and send an email off to Astrohaus and explain our little error and see if they can't help us. And they were very, very kind and were able to send me replacement keys for the 1, 3, Q, and W. And the next part of this will be actually replacing those keys and also putting a hole in that little piece of plastic and see if we can't get the 2 key to come back to life. Here you can see the unit at the end of part 1 of the repair, and these are the keys that we're going to replace. Astrohaus sent new keycaps for 1, 3, Q, and W, and also new scissor mechanisms to replace the ones that were there. So the next step is to pull the plastic insulator out, and we're going to put a hole in that. And we need a new nubbin or rubber nipple. Now from the last project, I had disassembled a keyboard, and that keyboard became a cadaver keyboard, and so we'll use the rubber nipple from that. I'll trim it down to fit our keyboard, and I'll also reinsert the plastic insulator with the hole punched through it. And now we'll put our number 2 key back on and replace the brand new 1, 3, Q, and W keys, and we're nearly good as new. The number 2 key is slightly higher than it was before, but you can see from the test here that the keys appear to work pretty well. And the number 2 key is no longer repeating, and the other keys are working as expected. So our little side project is complete. Thanks to Astrohaus, who are not sponsoring this video, for sending the keycaps that I needed. They were really helpful. I kept in the errors that I made because I think it's important to learn from our mistakes. So looking back, I didn't really need to remove the rubber nipple. That then caused me to use some heat, which damaged some keycaps. All I really needed to do was slide this plastic insulator between the contact and the membrane. And then when I didn't show it here, but I used a soldering iron to melt a hole in that piece of tape. Now that's some high temperature tape, so it made a very clean little puncture. So the next steps will be to either put a microcontroller inside of this and connect it to the LCD display in the keyboard, or reprogram the Freewrite to do something other than its intended purpose. So the project is a success. The keys are working the way that they should. And as usual, don't subscribe to this channel. Please don't click here or there. Your time is precious. Thank you so much for spending part of it with me, and I hope you gained some value from watching this today. So take care, and I'll see you next time on Dr. Frankentosh.